Using number 4 white wire, even with color coding at the ends, is not a recommended practice and goes against electrical codes and standards. These codes mandate color-coded wires to guarantee safety and accurate identification within electrical circuits. Typically, number 4 white wire serves as a neutral conductor. Employing it as a hot or energized conductor can lead to ambiguity and potential safety risks. The National Electrical Code, or NEC, specifically dictates the use of color-coded insulation for energized conductors, often called hot wires. This makes it easy to differentiate them from neutral and ground wires. Common colors designated for hot wires include black, red, and blue. While you might consider color coding the ends of a number 4 white wire, this approach can still introduce potential errors and confusion, particularly when future work is performed on the electrical system. Identifying which wire is neutral and which is hot could become challenging, thereby increasing the likelihood of electrical accidents. It is always best to adhere to electrical codes by using the appropriate color-coded wire for each specific application. This practice ensures clarity, safety, and compliance with industry standards. Electrical codes are in place for very specific reasons. The use of color coding makes it very clear what wires are for, and reduces risk of electrocution. Using white wire for hot applications will cause confusion down the line. If a future electrician is not paying close enough attention, this could result in electrocution or death. It is critical to have the right color coding. If you do not, it should be redone the right way. Do not leave it for someone else to fix later. The NEC has different rules on sizing, wire usage, and voltage. An electrician needs to take all of this into account before starting any work. There are multiple reasons for this. Firstly, safety is of the utmost importance. Secondly, to avoid violating any local or federal laws. Finally, not following NEC standards can result in fines and penalties. There are many different types of electrical codes, and they vary based on state, county, and city. Always make sure to understand the exact laws. When in doubt, hire a professional electrician. This professional electrician can review your plans and make sure they are up to code. The electrician can also implement the electrical plan. A professional will also be able to pull the right permits with the city or county so that you do not have to worry about it. There are many reasons to hire an electrician. Electricians have spent years studying this field. They have spent countless hours learning the trade. They have also been certified by the state. It is not worth risking your own life by trying to perform electrical work yourself. Without the right training, you can cause harm to yourself or others. There are many different applications of electricity. Whether it be a 120-volt circuit or a 480 volts three-phase circuit, they all require the proper safety. Make sure to get the right voltage tested before starting. When working with electricity, always turn off the breaker. Then confirm with the multimeter that the circuit is de-energized. Then you can go ahead and start the work. Without doing these things, it is very easy to get hurt. Most electrical accidents happen when people are rushing or not paying attention. Electricity should always be respected. The NEC outlines the proper usage of wire sizing based on circuit amperage. Firstly, you must identify the amperage of the circuit. Secondly, you must identify the length of the wire run. This is important for voltage drop calculations. The longer the wire run, the larger the wire needs to be. Thirdly, you must identify the type of wire. The most common types of wire are copper and aluminum. Copper is a better conductor than aluminum, but it is also more expensive. Aluminum is typically used for larger wire sizes. Fourthly, you must identify the insulation type of the wire. Common insulation types are THHN, THWN, and XHHW. Each insulation type has a different temperature rating. Based on the temperature rating, you can determine the ampacity of the wire. Fifthly, you must refer to NEC Table 310.15 to determine the ampacity of the wire. This table takes into account the wire size, insulation type, and temperature rating. Once you have determined the ampacity of the wire, you must make sure that it is greater than or equal to the amperage of the circuit. If it is not, you must increase the wire size. It is also important to consider dirting factors. Dirting factors are used to reduce the ampacity of the wire based on certain conditions. For example, if the wire is installed in a conduit with other wires, the ampacity must be derated. The NEC provides tables that specify the dirting factors for different conditions. It is also important to consider voltage drop. Voltage drop is the decrease in voltage from the source to the load. Voltage drop is caused by the resistance of the wire. The longer the wire, the greater the voltage drop. The NEC recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times length times current times resistance per 1000 feet divided by 1000. If the voltage drop exceeds the recommended limits, you must increase the wire size. It is also important to consider the ambient temperature. The ambient temperature is the temperature of the air surrounding the wire. The higher the ambient temperature, the lower the ampacity of the wire. The NEC provides tables that specify the ampacity correction factors for different ambient temperatures. It is also important to consider the number of conductors in a conduit. The more conductors in a conduit, the lower the ampacity of each conductor. The NEC provides tables that specify the ampacity adjustment factors for different numbers of conductors in a conduit. It is also important to consider the type of load. The type of load can affect the ampacity of the wire. For example, a motor load requires a larger wire size than a lighting load. The NEC provides tables that specify the ampacity adjustment factors for different types of loads. It is also important to consider the overcurrent protection device. The overcurrent protection device is a circuit breaker or fuse that protects the wire from overcurrent. The overcurrent protection device should be sized to protect the wire. The NEC provides tables that specify the maximum overcurrent protection device size for different wire sizes. When selecting wire, it is very important to consider all of these factors. If you are not sure how to select the correct wire size, you should consult with a qualified electrician. Using the wrong wire size can be dangerous and can cause a fire. This is why it is important to follow the NEC guidelines. The NEC is updated every 3 years. It is important to stay up to date on the latest NEC requirements. You can purchase a copy of the NEC from the National Fire Protection Association. You can also find information about the NEC online. There are many resources available to help you understand the NEC. If you have any questions about the NEC, you should consult with a qualified electrician. An electrician can help you understand the NEC requirements and can help you select the correct wire size for your application. Using the wrong wire size can be dangerous. It is important to follow the NEC guidelines and to consult with a qualified electrician if you have any questions. There are many different types of wire. Each type of wire has its own unique properties. It is important to select the correct type of wire for your application. The most common types of wire are copper and aluminum. Copper is a better conductor than aluminum, but it is also more expensive. Aluminum is typically used for larger wire sizes. There are many different insulation types. Each insulation type has its own unique properties. It is important to select the correct insulation type for your application. The most common insulation types are THHN, THWN, and XHHW. Each insulation type has a different temperature rating. The temperature rating of the insulation is the maximum temperature that the wire can withstand. It is important to select an insulation type that has a temperature rating that is high enough for your application. There are many different sizes of wire. The size of the wire is measured in American wire gauge, or AWG. The smaller the AWG number, the larger the wire. For example, a 12 AWG wire is larger than a 14 AWG wire. It is important to select the correct wire size for your application. The correct wire size depends on the amperage of the circuit, the length of the wire run, and the ambient temperature. The NEC provides tables that specify the correct wire size for different applications. It is important to follow the NEC guidelines when selecting wire. Using the wrong wire size can be dangerous and can cause a fire. It is also important to consider the voltage drop. Voltage drop is the decrease in voltage from the source to the load. Voltage drop is caused by the resistance of the wire. The longer the wire, the greater the voltage drop. The NEC recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. If the voltage drop exceeds the recommended limits, you must increase the wire size. It is also important to consider the ambient temperature. The ambient temperature is the temperature of the air surrounding the wire. The higher the ambient temperature, the lower the ampacity of the wire. The NEC provides tables that specify the ampacity correction factors for different ambient temperatures. When installing electrical wire, it is important to follow the NEC guidelines. Firstly, you must turn off the power to the circuit. Secondly, you must use the correct tools. Thirdly, you must make sure that the wire is properly insulated. Fourthly, you must make sure that the wire is properly grounded. Fifthly, you must make sure that the wire is properly supported. Sixthly, you must make sure that the wire is not damaged. Seventhly, you must make sure that the wire is not exposed to moisture. Eighthly, you must make sure that the wire is not exposed to chemicals. Ninthly, you must make sure that the wire is not exposed to extreme temperatures. Tenthly, you must make sure that the wire is not exposed to physical damage. Following these guidelines will help you to install electrical wire safely and correctly. The NEC is a complex document. It is important to consult with a qualified electrician if you have any questions. An electrician can help you understand the NEC requirements and can help you install electrical wire safely and correctly. Never attempt to do electrical work if you are not qualified. Electrical work can be dangerous and can be fatal. If you are not sure how to do something, you should consult with a qualified electrician. Electrical codes are constantly changing. It is important to stay up to date on the latest electrical codes. You can purchase a copy of the electrical code from the National Fire Protection Association. You can also find information about electrical codes online. If you have any questions about electrical codes, you should consult with a qualified electrician. It is also important to consider the type of conduit. Conduit is a tube that protects the wires. There are many different types of conduit. Each type of conduit has its own unique properties. It is important to select the correct type of conduit for your application. The most common types of conduit are rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid non-metallic conduit. Each type of conduit has its own unique properties. It is important to select the correct type of conduit for your application. It is also important to consider the size of the conduit. The size of the conduit is measured in inches. The larger the conduit, the more wires it can hold. It is important to select the correct size of conduit for your application. The NEC provides tables that specify the correct size of conduit for different applications. It is also important to consider the number of bends in the conduit. The more bends in the conduit, the more difficult it is to pull the wires through the conduit. The NEC recommends that the number of bends in a conduit run should not exceed 360 degrees. It is also important to consider the type of fittings. Fittings are used to connect the conduit to other components. There are many different types of fittings. Each type of fitting has its own unique properties. It is important to select the correct type of fitting for your application. It is also important to consider the grounding of the conduit. The conduit must be properly grounded to protect people from electric shock. The NEC provides guidelines for grounding conduit. Following these guidelines will help you to install conduit safely and correctly.